I think screen is visible to you everyone. This is the continuation of the last class, that is in which we have discussed about discussed about the partial fractions. That is the last class we have discussed about the Laplace transformation and inverse Laplace transformation. Okay, and you know that for Laplace transformation, if this kinds of solution or these kinds of problems occurs like this, where denominator is something like a factors of two parts, that is s minus 2 or s minus 7 or this. Okay, so I've already discussed any partial fraction rules. Okay, so this is my first question. Today, this is a since this is a continuation, and I have already solved many questions about this partial fraction. So this is a continuation. So I want you to solve this first. How to put this expression 3s plus 4 divided by s minus 2 into s square plus 7 in partial fraction. Okay. So first I will I'm going to give you a couple of minutes to solve it. Put it into the form of partial fraction and find the value of a, b and c. That is the constant values. So please solve it and write it into the chat box. Just the form of partial fraction. One by s minus 2 plus 1 minus is by s square plus 7. Okay, I've got one answer. Any other answer? 1 minute more. Okay, now I will solve it. First of all, look at the denominator term, s minus 2 s square plus 7. If s square plus 7 term is, look at this, s square plus 7, it is a square term of s. Okay, that is a second degree term of s. I always suggest you, if this term, any kind of square term or cubic term is there, I want you to put it in factorized form. That is s square plus 7 can be factorized with some real number, not an imaginary number. Okay, a square plus 7 can be factorized, but the factor can be factor may be imaginary. Okay, so if with real number it can be factorized like this, if instead of a square minus 7 a square plus 7, suppose it is a square minus 7, now it can be factorized like this, s plus root 7 into s minus root 7. So I suggest, if this term, square term, can be factorized, then factor it and convert it into any linear form of s. Okay, that is degree of s should be 1. Okay, that is, if this persists, that is s square plus 7 is there, then you can easily write it like this, s minus 2, okay, s plus root 7 into s minus root 7 is equal to a by s minus 2 plus b by s plus root 7 plus c by s minus root 7, like this. But since s square plus 7 is cannot be factorized, so that's why there is another form of this. The form is this one. Okay, so s minus 2, 3s plus, just forget about the numerator term. Okay, don't bother about what is in numerator. Always bother about the denominator. Okay, and denominator exists s minus 2 s square plus 7, and s square plus 7 cannot be factorized. So in this case we will divide it like this, a by s minus 2 plus bs plus d. Okay, this is very important. Since it cannot be factorized and s square plus 7 is there, if it is a square term, always use b s plus d. p a d, everything is constant. This is constant, this b is constant, this d is also constant. Okay, so bs plus d divided by s square plus 7, this is the form, okay, of uh, partial fraction if this term cannot be factorized. Okay, now what is the next rule? Next rule is very easy. Just simply calculate it, simple calculation, or simplify this term. Okay, so after simplification you can see that this term, that is, if I simplify this term, it becomes s minus 2 and s square plus 7, and after a into s square plus 7 plus bs plus d into s minus 2, and multiply everything, and we compare both sides. As accordingly we have already compared and solved the values of a and b in the previous day in the last class. Exactly in the same way we will compare both sides and find the values of a, b, c. So we have got, after comparison, we have got three equations: a plus b equal to 0, minus 2b plus d equal to 3, and 7a minus 2d is equal to 4. Okay, and after solving these three equations, we can see, this is from this equation we can see that a equal to minus b. Okay, so simply you can put the value of a here equal to minus b, or simply put the value of b equal to minus a here. Find the value of a, b and d. A, b and d. Okay. Then what is the partial fraction? This is just simply put the value of a, b and d. It will become like this. Okay. So what is the value? 10 by 11. So 10 divided by 11 into s minus 2 plus what is the value of b? B is minus 10 by 11. Obviously, A equal to minus B. So minus 10 by 11 into S plus D. What is the value of D? 13 by 11 divided by S square plus 7. So this is the form of the partial fraction. Okay. So just you need to remember these formulas of partial fraction. Formula of partial fraction. What is the, just look at the denominator, whether the denominator is linear in s, that is the degree of s is 1, or the quadratic form in x. If it is in quadratic form, then is it it can be factorized or not. If it is factorized, it can be factorized, then factorize it. Otherwise, solve by using this formula.
So if the denominator is having a cubic equation, then should we increase the power in the numerator?
Exactly. Then it will be a plus a s square plus b s plus d. If it is cubic, suppose a plus 7 or like this, then also try to factorize it with linear form. Okay, I already have discussed the how cubic equation can be factorized. So according to that that process, if you can factorize the cubic equation, then it is very good. But if you can't factorize the cubic equation, then just simply increase the, okay, it will be a plus s plus c square like this, and within a denominator it will be some cubic equation of s. Okay. So this is all for the Laplace transformation, and always try to find just practice it, because partial fraction, okay, and converting of the inverse Laplace transformation, okay, you need practice for these maths, otherwise it is very difficult to solve. So our today's chapter is one of the most important, which is differential equation. And you know that every field, every engineering field without differential equation is cannot be performed. Okay, any kind of mathematical equation, and you will face the differential equation of that, and you have to solve it. Most of the cases numerical methods is used. Okay, but in some cases it is better to find out the classical method, find out the solution using classical method rather than the numerical. Okay, so let's start with this. So first, differential equation, it consists of this theory for of order and degree, and I have faced many questions about order and degree of a differential equation. So tell me, I think you have learned this order and degree of differential equation. So if you remember, please tell me and write it in the chat box. What is the order and degree of this differential equation? I want the answer from everyone. Please participate, everyone. Only two people just answering these questions. It's not acceptable. Please participate, everyone. Order and degree is very necessary, and you will find many questions about this order and degree. And it is very easy. I think you have already learned. Okay, so let's uh, remember it again. First of all, what is order? Order is nothing but the highest differential. Order means highest differential. Okay, highest differential, it means the highest differential order. So what is the highest differential here? You can see this is dy dx. That is dy dx is first order differential. This is d4y dx4, fourth order differential. There is no other differential here. So that is why the highest order of this differential, or the highest differential, is 4, d4 dx4. So the highest differential is fourth order. So it means the order of this differential equation is equal to 4. And what is degree? Degree is what is the power of the highest differential. Okay, it is power of highest differential. Okay, so look at this. What is the power of highest differential here? The power of highest differential is 1. This is to the power 1. d4y dx4 to the power 1. Okay, since this power dy dx power is 3, but we don't consider this because dy dx is first order differential. So what is the highest power? Fourth order. There is d4 dx4. This is the fourth order differential, is the highest order. So what is the power of the highest order? Highest order power is 1. Okay, so that is why we consider the degree of this differential equation is equal to 1. One thing should be remembered, very important point. Degree can only be found if the differential equation is in polynomial form. Polynomial in dy dx. If it is polynomial in dy dx. What do you mean by polynomial in dy dx? Look at this. Dy dx term, differential dy dx term, is not in any sine function or exponential function or logarithmic function. It is a polynomial function here, that is only dy dx term is present. Okay, as an example, I'm giving you an example where you cannot find the degree. Look at this differential equation. I'm just giving you an example. D3y dx3 plus sine of dy dx is equal to 3. Can you tell me what is the order? Please write down in the chat box what is the order. Yes, order is 3. Degree? Again, I told you, look at this. This is not in the form of polynomial. Sine of dy dx. Sine of dy dx, it means it is the trigonometric form of dy dx function. Okay, trigonometric form of dy dx. But look at this one. Look at this one. This is not a trigonometric or exponential or this one. Nothing else. Nothing is there. Only you can find the degree of the differential equation if it is in polynomial form. That is dy dx. Only dy dx is there. You cannot find any kind of sine of dy dx, cos dy dx, or like this. Then you can't find the any kind of degree of that equation. Okay. Similar equation can be found. Suppose dy dx log of dy dx. Okay, plus y is equals to 0. What is the degree? No degree, because this is not a polynomial in dy dx. Okay, any doubt?
No, sir.
Okay, so this is very important thing.
So degree is 0 here.
Yes, degree is 0 or no degree. Cannot be defined.
Okay, sir.
Next. Order and degree of this equation. Please write down in the chat box. Look at this. This is also not polynomial function in dy dx. Okay, because root over function, it is the power of half. Okay, root over means it is half is the power. Polynomial function always the power of 0, 1, 2, 3, 4, 5. That is integer power. Okay. So can you find the degree or order of this differential equation or not? Term is there. There is no other differential term. And what is the power of this differential is 2. So degree is 2. Okay. Next. Okay. This is a great question. So what is the order of the differential equation? Yes, this is very easy question. Order of this differential equation is 2 because this is the highest order, d2y dx2 or d2y dt2. Next step, the order and degree, it is clear to you. Now the next step, solving of differential equation. Tell me which one of the following is the solution of the differential equation this. Can you do this or not? If you can't do this, then tell me. I will make you understand. I'm just giving you one example. After that, you can solve it. So, can you solve it or not? Just tell me in the write down in the chat box. I will discuss it then. Okay. So let's discuss about the solving of differential equation. Most important part of differential equation is solving. You will find many questions about that is I have found many questions of this ordinary differential equation in GATE questions. So you have to careful about this. There is this kind of solution. Obviously, you will find in GATE. So first of all, I'm giving you an example. Then I am calling you to solve it. Just example is, suppose dy dx, okay, minus y. Suppose first minus x is equal to 0. How to solve it? The solution technique, there are two kinds of solution technique. One is to find whether the equation is exact or not. Okay, that exact equation form I will discuss it later. First of all, another very important and easy way to find the solution of differential equation is separation of variable method. What is variable separation? Just separate y and separate x. Okay, how to separate it? Look at this, dy dx, I can write it like this. Now we have to take this dx with x and dy with y. Okay, variable separation. So obviously there is no y, so dy can be taken here in the left hand side, and we can take this dx with x. My job is done. Now simply integrate both sides. Now integration can be done whenever you are separating the variables, that is x with x, dx with all x terms and dy with all y terms, you can easily integrate. Then integration both sides plus c, integrating constant. Okay, whenever we take an integration, obviously we will put an integration constant here. And after solving this, we can see that dy, what is the integration of dy? Obviously it is y. What is the integration of x dx? It is x square by 2 plus c. So this is the solution of the differential equation. Okay, now this is called general solution, GS. Why it is called general solution? Because a constant term is there. Okay, now how can we remove this constant term? If some condition is given to you, some boundary condition or initial condition. Suppose along with this differential equation, a condition y0 equal to 1 is given. Then you can easily find the value of c. Put here y0 equal to 1, it means y is equal to 1 when x is equal to 0. So now put it into this equation and you can easily find the value of c. Okay, y equal to 1 and x equal to 0. Put x equal to 0 and y equal to 1. Is 1 is equal to 0 by 2 plus c. So what is the value of c? C equal to 1. Put the value of c in this general solution, that is y is equal to x square by 2 plus 1. This is called particular solution. This is called particular solution. Okay, and we including c is called general solution. Particular solution can be obtained if some condition is given to the equation. Otherwise, you can only find general solution. Okay, so the same case happens with this differential equation, what is given in the question also. Just try to separate the variables, x with dx, all the x term with dx, all the y term with dy, and then just integrate both sides. You will have your answer. Now tell me which answer. Did you understand how to solve it? If you have any doubt, then tell me. I will discuss it again. Can you solve it now? Here xt is nothing but just xt, just consider xt as y and nothing else. Okay, consider xt as y. That is, this equation now becomes dy dt plus 3 into y is equals to 0. Now solve it. Just separate y as y with dy, and the other, that is t variable, with t. If there is no t, just separate dt separately and then integrate.
Sir, in the options, all the options are given in particular form, particular solution form, but
Yes.
there is no conditions given, no initial condition or.
Then you have to check that which solution fits or which solution suits the most well with this particular solution.
So
Okay.
then it's
Look at
option
this.
B.
Look at this, each and everything. This is e to the power minus 1, e to the power minus 3t, t square, t square, 3t square minus 3 by 2 t square. Okay. If this exponential form, then look at this, the power of exponential is different both sides. Okay. This thing, that is 3 2 whatever the constant term is given to you, that is different case. But at least first find the general solution. Obviously that general solution meets with any one of these function, either t square or exponential function. Just choose that general equation, general solution, you can find your answer. Okay, two students says that B is the right answer, so they already found what is the general solution. This is the fund of MCQ questions. They will not give you any boundary conditions or initial condition. This is initial condition, not boundary. Okay, but the solution, the options given to you will be in the form of particular solution. In that case, you just need to find which fits the most. Okay, let's solve it. dy dt is equal to minus 3y. Okay, solve, separate the variable, dy by y is equals to minus 3 dt. Integrate both sides. Integrate both sides. Dy by y is equal to minus 3 dt plus c. This is log y is equal to, suppose log c. Okay, just take it as log c. Okay, it will fit better, best. Log c. Okay, just c, not log c. And this is minus 3 t plus c. So this is y is equal to e to the power minus 3t, okay, plus c. So it means this equal to y equal to e to the power minus 3t into e to the power c. Am I right or not? Log y is equal to e to the 3t minus 3t plus c. If I just nullify this log, or omit this log, then it means y is equals to, it becomes e to the power, and whatever in the right hand side, it will go to the power of e. If I just nullify this log, then y is equal to e to the power, whatever the right hand side, that will be in the power of e. This is the formula. Okay, then y is equals to e to the power 3t plus c. Then you can easily write it e to the power 3t minus 3t into e to the power c. If I multiply these two, you can get this one. E to the power c is a constant term. So you can now tell me which solution fits the most. Look at this, e to the power minus 3t. Which solution, which options has e to the power minus 3t? Obviously B, e to the power minus 3t is there. Now whatever the constant term, just forget about the constant term. This solution e to the power minus 3t fits with this one the most. So obviously B is the right answer, because this is e to the power minus 1. It cannot be fitted. This is a polynomial function. This is also polynomial function. Obviously it cannot be fitted. Okay. Any doubt? Any queries? Next. For the differential equation dy dt plus 5y equal to 0 with y0 equal to 1, what is the general solution? This is actually particular solution. The question is actually wrong. This should be particular solution, not general. Okay. Any other answer? 4, 1, 2, 3, 4, 5. 5 students says B. Anyone else? Very easy. This is. You can easily find out. Simply variable separation method. Whatever I have taught you, variable separation dy dt is equal to, obviously it is minus 5y, same as the previous question. So dy by y is equal to minus 5 dt. Okay, so if I integrate both sides, plus c, after integrating we can have it like this log y, okay, is equal to minus 5t plus c. Okay, so this is equal to y is equal to e to the power minus 5t plus c. C to the power minus 5t, it means what, y equal to e to the power minus 5t into e to the power c. Okay, another thing you can also do. Okay, let's find it now. Y0 equal to 1. Y0 is equal to 1. It means, okay, y equal to e to the power minus 5t equal to e to the power minus 50. Here also e to the power minus c and b. There are two options, c and b, which includes e to the power minus 5t. This is e to the power plus 5t. This is e to the power root 5t. Obviously a and d will be nullified here. Now you have to find out by using this boundary initial condition, y0 equal to 1, that is, put the values. When x equal to 0, y is equal to 1. Put the value of x and y, that is t here. This is not x, this is t. So if I put this 0, so e to the power c is equal to 1. So obviously it means c is equals to what? C is equals to 0. E to the power c is equals to 1. And 1 means what? 1 means we can write 1 as e to the power 0. C to the power 0 means if we compare both sides, it is c equal to 0. C equal to 0 means it becomes e to the power c, it becomes 1. So y equal to e to the power minus 5t. Y equal to e to the power minus 5t is B. B is the right answer. Okay, very easy. Next question. Consider the differential equation dy dx equal to 1 plus y square. Which one of the following can be a particular solution of the differential equation? I've got only two answers, Mohit and Samarth. What about the others? You need to remember the integral rules. Okay, many have answered. Most of you have said B. So let's find out. Okay, someone says A. So first of all, if we look at this is the same kind of questions where no initial condition is given to you. Okay, no initial or boundary condition is given to you. Only the equation is given. So by finding only the general solution, you have to choose which of these options will suits the most or fits the most. Okay, let's find out the solution. Dy dx equal to 1 plus y square. So separate the variables. Only y is contained. So dy divided by 1 plus y square is equal to dx. We can write it like this. Okay, dy by 1 plus y square. If I integrate both sides, integration of dy by 1 plus y square, this integration of dx plus c, suppose dy by 1 plus y square, it is tan inverse y. Okay, look at the integral rules which you have already learned in class 11, I think, 11th class. This is equal to x plus c. Okay, so which is equal to nothing but y is equal to, since it is tan inverse y, so we can write it tan of x plus c. So y equal to tan of x plus c. So tan of x plus c, which one of the solution fits the most? Which one of the solution of these options fits the most? Obviously a. Y equal to tan of x plus 3 fits the most. So it is not b, it is a is the right answer. Okay, and what you have just mistaken, that is y equal to, you just took the tan inverse x like this. You didn't take c within this tan inverse. That is a mistake. X plus c, it means the whole term x plus c will be in the tan. Okay, any doubt? Next. Only 1 minute I will give you for this question. Okay, everyone have answered. So let's find. It is very easy question. Dy dx is equal to y square, means it is minus y square. This implies dy by y square is equal to minus of dx. You can easily solve it like y square integration of dy by y square equal to minus of dx plus c. Okay, it means it is y square. So y square means y to the power minus 2. Y to the power minus 2 plus 1. It means y to the power minus 1 by minus 1. Just simply integration rules. Minus x plus c. Okay, so y is equals to, so x plus c, if I 1 by x minus c. Yes, if I take the minus sign here, then it becomes this one, y equal to 1 by x plus c. A is the right answer. Okay, two ways. You can put the minus sign here, you can put the minus sign here also. So if we put the minus sign here, then this answer matches with A. But if you do not put the minus sign in left hand side, you can also put the minus sign in right hand side also. If I put the minus sign in right hand side, the answer may change. But there is no option like that. So that is why you have to put the minus sign in the left hand side. So A is the best answer. Next one. The solution of the differential equation dy dx plus 2xy equal to e to the power minus x square with y0 equal to 1 is equal to what? This is not like the previous questions what we have discussed right now. This is the questions of linear equation, one of the most important VVI form of first order first degree differential equation, which is called the linear equation. Linear equation. The form of this equation is like this: dy dx plus px into y plus qx. That is, p and q are the function of x. So dy dx, exactly the form will be like this: dy dx plus p into y plus q. P and q are function of x. Now, if I recall this equation, okay, if I recall this equation, I am writing down the equation dy dx, just compare, plus 2xy is equal to e to the power minus x square. Just compare with this. Okay, so in the place of px, that is p, what is here? 2x. So p is equal to 2x, or px equal to 2x here. And in the place of qx, q is also another function of x. Okay, in the right hand side, the qx function is totally this entire function e to the power minus x square. Okay, so obviously it matches with the linear equation. So we can say this is a linear differential equation. It is a special form of first order first degree differential equation, and there is a particular solution type also. You don't have to solve this linear differential equation by using the previous rules. It will be difficult for you. But if there is a particular integrating factor means a multiplication by some term. Okay, I will discuss the integrating factor or whatever later. But first, I have to discuss how to solve it. Okay, do you know about linear equation? Yes, obviously you know, but do you remember this? How to solve it? No. Okay. I am explaining this with very easiest way. I'm not going to. There is many story behind this linear equation. How to solve it? What is integrating factor? Okay, everything you have to know. Then you can solve this differential equation. But I'm not going to tell that story because it will take many times. So that is why I'm just saying some steps. First step: if you face any differential equation which is in linear form, remember step 1, you have to multiply both sides. Multiply both sides with a term, and this term is called integrating factor or IF. What is IF and what is this? Just forget about that. I am not going to discuss. IF means integrating factor. Okay, so whenever you face any differential equation, just multiply both sides with integrating factor. And what is the integrating factor? Always the formula is this. IF formula is e to the power integration of p dx. This is a fixed formula which is used to solve linear differential equation and you have to remember it. Okay, now just simply solve it. The IF, so you have to first find the IF and then you can multiply both sides. So IF is e to the power integration of what is P here? 2x dx. So it means e to the power 2 into x square by 2. So it means x square. Am I right or not? Did you understand this step? If you understand this step, then don't understand this step, then tell me, I will explain it again. So to solve any linear differential equation, first you need to find out the integrating factor, and this is the fixed formula, e to the power integration of p dx. You already have what is p, you already have what is q. Okay, so integration of e to the power integration of p dx, just follow this formula, e to the power x square. Is there any doubt here in this step? Okay, if you do not have any doubt, then go to the next step, multiplication. Step 2, or it is also step 1, you can multiply. So now multiply both sides by this integrating factor. Multiply here, e to the power x square plus 2x y is equal to e to the power x square into e to the power minus x square. Simply multiplication and nothing else. Okay. After multiplication, the right hand side, left hand side, the left hand side, it becomes like this, d of y into e to the power x square. Why? Did you understand this step? Why did I write this step, that is this whole term, e to the power x into this one, by this d of y into e to the power x square? Did you understand this one? No. Okay. Simply take the derivative. If I take the derivative, this is multiplication form, u into v form. Derivative of y, e to the power x square is fixed, plus derivative of e to the power x square, y is fixed, isn't it? So simply multiply form, derivative, take the derivative by using a multiply form. So first one is e to the power x square is fixed, the derivative of y is dy dx, plus now y is fixed, the derivative of e to the power x square, it is 2x e to the power x square. Now match with these two terms. Is this two term equal or not? These two terms equal. So can I write this one, x e to the power x square into dy dx plus 2xy, with this one, d of y into e to the power x square? We can write it. So this is the funda. You just need to remember. I'm just telling you, I'm just discussing this to make you understand how it came. Okay, how it can be derived. You don't need to understand all these things. There is a fixed formula. Always it is y into integrating factor. Okay, the same things repeats for every question, whatever the linear equation is. So you don't have to derive this one. You just need to remember this one, nothing else. Just I have discussed this one just to make you understand how it derived. Next, e to the power x square, e to the power minus x square, it becomes 1. Okay, your task is done and there is nothing else. Now simply integrate both sides. Okay, how can you integrate it? Sorry, this is ddx. Okay, this is ddx of this one. So this implies now d of y e to the power x is equals to dx. Just integration. After integration, both sides integrate plus c. After integration, it will become y into e to the power x. It will become only x plus c. Okay, now
Excuse
it's
me.
done. Yes,
I'm having a doubt, sir.
yes,
Initially, it was written that d by dx of y into e to the power of x square.
yes,
So by using the UV rule, we got u dash v dash plus v dash u something.
exactly. Yes.
Okay, that term came. Plus, we have to multiply 2xy into e to the power of x square, no, sir. We have to add that term, right?
I didn't understand.
Okay, fine. So I'll tell you. Dy by dx into e to the power of x square, one term is done. The second term
Yes.
is 2xy into e power x square that has to be added.
Yes, obviously.
Where is the added term, sir?
I just erased it. Look at this. If I look at this, it is e to the power x square. Okay, fixed dy dx plus
Huh. Yeah,
okay
yeah. Yes.
y 2x e to the power x square.
Ah, it is the differentiation.
Yes, differentiation.
Yes, sir. Yes, sir.
Now match with this term and this term. If I just take e to the power x square common, then it becomes inside term, it becomes dy dx plus 2xy.
dy. Yes, sir. Dy by dx plus 2xy.
xy
Correct.
into e to the power x square. This is the same term.
E to the power of x square is taken out. Okay.
Yes, taken out. Isn't equal or not?
Oh. Okay. Yes, sir. Yes, sir. It is equal.
Okay. So that is why we can easily write it ddx of y into e to the power x square.
Okay. Fine, fine, sir. Fine, sir. I got it.
Okay. Now after integration, tell me what is the answer? B is the answer. Okay. Now everybody integrate it and tell me the answer. Two students says Abhijit and Samarth says B.
Sir, you have written only e power x, sir. It should be e power x square.
E to the power?
E to the power x square, sir. In below, sir, bottom.
This one?
Y.
Sorry. Okay. Sorry. So which answer fits the most? Which answer fits the most? Y equal to what now? B or D? Is there any? No, it is not D because it is x plus c. Look at this. If I convert it y equal to, it becomes c to the power minus x square into x plus c. Okay, so it means x plus or x minus something. Okay, x plus or x minus, but d is 1 minus x, that is before x there is a minus sign, which is not possible. So b is the only answer, 1 plus x or x plus 1. It can be only feeds the most or best. D is 1 minus x, but here we can see that before x there is no minus term, so we can't take d. Okay, got my point?
Yes, sir. Got it.
Okay, so I am giving you another question of linear equation. Solve it. I'm not giving you the option. I'm giving it by myself. It's not a gate question. Just to try to understand that how you can understood my point.
Sir, unable to see the question.
Sorry,
Question is not visible, sir.
question not visible. No, I didn't give you any question. I am just giving you the question right now. Okay, so tell me, what is the answer of this differential equation? Just find the integrating factor. Okay, IF. After integrating factor, don't need to solve it. What is IF? If you forgot the IF, then I am writing the formula of IF again. IF is equals to e to the power integration of p dx or e to the power integration of p dy. Depends on which one is the independent variable, x or y. I think I need to solve it. It will be difficult for you. Look at this. There is a trick in this question. The trick is like this. If you just find dy dx, okay, you can't find any linear equation here. Okay, let's see. If I find dy dx here, e to the power tan inverse y is the integrating factor. Yes, e to the power tan inverse y. Samarth, you are right. Exactly. Exactly, e to the power tan inverse y. Okay, look at this. If I find divide x, it becomes y is there 1 plus y square divided by tan inverse y minus x. This equation doesn't follow any rule for linear equation, that is dy dx is equals to p into y plus dy dx plus px is equals to q. You can't find any equation or any kind of form like this. That is why in this case we have to turn this differential equation as dx dy, that is exactly the opposite form, and we need to find the solution as x equal to something. Okay, Mohit says that x equal to 1 plus e to the power c into e to the power minus tan inverse. Okay, the solution is here x equal to tan inverse y minus 1 plus c into e to the power minus tan inverse y, not 1 plus. There is another tan inverse y. Okay, let's see. Now just simply we will do the things like this. It is dx dy. We will find here dx dy. Okay, dx dy, and now it becomes 1 plus y square. Sorry. Tan inverse y minus 6 divided by 1 plus y square. Okay, tan inverse y minus x divided by 1 plus y square. Now simply divide it both sides. If we separate this one, we can write this like this: tan inverse y by 1 plus y square minus x by 1 plus y square, and we can write it like this: dx dy plus 1 by 1 plus y square x is equal to tan inverse y divided by 1 plus y square. Can I write it like this? Instead of finding dy dx, I am finding dx dy here. And look at this, this becomes linear equation in x, not linear equation in y. Okay, so same case happens, just we are interchanging x with y and y with x and nothing else. In the previous equation, look at this here, x is an independent variable. But here in this equation, we convert it as y, that is y is the independent variable. Okay, so this is, if we compare, it becomes dx dy plus p qy. Look at this, this is another form of linear differential equation, just replacing x with y. The previous form was dy dx plus px into y is equals to qx. This is the previous form. But we can find another linear differential equation where if I consider y as independent variable, the same thing, the same equation. Look at this, just interchanging x and y and nothing else, and you got the form. So same type of integrating factor we will find here also. So what is the integrating factor here? The previous one, in case of previous one, integrating factor was e to the power integration of p dx. In this case, the integrating factor will be e to the power integration of p dy, because y is treated as an independent variable here. So if is equal to e to the power integration of what is p? This was 1 by 1 plus y square dy, and just you solved. What is 1 by 1 plus integration? Tan inverse y, e to the power tan inverse y. Okay, so e to the power tan inverse y is the integrating factor here. Now simply multiply both sides by integrating factor and you can find the solution. This is the differential equation. Just multiply e to the power tan inverse. So I am writing the solution. The formula is, after taking the derivative, the formula is ddx of, sorry, here ddy of x into e to the power tan inverse y. That is independent variable into integrating factor. Look at the previous one. Independent variable into integrating factor. ddx of that. So do not just derive, just simply you can write it like this. Is equal to, multiply here, tan inverse y into 1 plus y square into e to the power tan inverse y plus, okay. Now after integration it becomes x into e to the power tan inverse y is equal to integration of tan inverse y by 1 plus y square e to the power tan inverse y dy. Okay, and now you can just put here tan inverse e to the power x. It is, you can put just tan inverse y equal to z or something, some other variable. Okay, change it like this. So after integration the value will be, yes, exactly, tan inverse y plus 1. Mohit, you are right. Samarth, you are also right. The answer is the same answer. This is equal to, x is equal to tan inverse y minus 1 plus c into e to the power minus tan inverse y. This is the answer of this question. Okay, so integrating, if only integrating factor is needed to be found, this is the technique to find out the integrating factor. E to the power integration of p dx or e to the power integration of p dy. Okay. Okay, so this is the linear form. Now we have to go to the second order differential equation. So far we have learned about the first order, first degree differential equation. Now we have to go to the second order differential equation. Okay, first of all, tell me any doubt you are having, any kind of queries. Okay, so let's go to the second order differential equation. Solve for y. That is, you need to find out the value of y. If d2y d2y dt2 plus 2 into dy dx plus y equal to 0 with y0 equal to 1 and y dash 0 equal to minus 2. Two conditions are given to you. Initial conditions are given and you need to find out the solution of the differential equation. Can you solve it? Anybody know what is the rules for second order differential equation with constant coefficients? Complementary function, particular integral. Do you know about this? Very important. I have seen this kind of this second order differential equation questions in each and every year of GATE questions. Even I have found it in last year, the last previous years, every year. this kind of equations, at least one questions will be there. So it is very important to know the solution of second order differential equation. Put dy dt equal to u. No, not like this. Is put dy dt equal to, you can put it d, capital D, or like this. Then it becomes d square. Yes, capital D. The question, okay, let's discuss. There is ddt. It is actually, you can say capital D. It is just an operator. Okay, different book have used a different operator or different symbol for that, but many books used this one, capital D. So ddt or ddx, it can be denoted by this symbol, capital D. If ddt is capital D, then the second order derivative, it is denoted by d square. The third order, d3, it is d cube, and so on. Similar things happens for this also. Okay, so this becomes d2y dt2, we can write it d square y plus 2 into, this becomes capital D y plus y is equal to 0. Okay, and after that, one trial solution should be considered. Y is equal to e to the power mx is a trial solution of this differential equation. So I'm not discussing about all these things. Okay, these things it has a theory part. I'm not discussing about it. I'm just giving I will discuss the shortcut trick how to solve it. Simply, after putting into this form, simply put it form, just put d square y is equals to m square, dy as m, and y as 1. Okay, so just put it y, just consider y as 1, y equal to 1, and d is equals to m, and put it here into the differential equation. Got my point? Just after whatever the differential, second order differential you have, okay, just put it into this form, d2y dt2, it means d square y plus 2 into y plus y equal to 0, dy equal to 0. After that, put y equal to 1 and d equal to m. This becomes a polynomial form. Simply find the value of m. M is equals to, what is the value? What is the value? 1 minus 1. Yes, minus 1. Not only minus 1. This is minus 1. Actually, this is a plus b whole square. M square plus 2m plus 1. What does it mean? M plus 1 whole square is equal to 0. So it means m plus 1 into m plus 1 is equal to 0. It means m is equals to minus 1 comma minus 1. Very important part. Not only 1, it is minus 1. Sorry, not only minus 1. It is minus 1 comma minus 1. There are two values because this power is 2. Okay. Now you need to remember 3 rules. The rules is, if the root of this equation, here the root is minus 1, that is equal and real, not imaginary. So there are 3 conditions. Okay, I am writing the conditions. write it with first condition is if the roots are real and unequal. Okay, real and unequal means suppose m is equal to m1 and m2, real and unequal m1 and m2, then the solution, it is called complementary function. Then the solution CF equal to a1 e to the power m1x plus a2 e to the power m2x. This is one. Second, roots are real and equal, just like the previous one. Look at this, real and equal. So what is the solution? a1 plus a2 x e to the power mx. Okay, real and equal means suppose m1 is equal to m2 is equals to m. That is, here m is equals to -1. So this is the solution. Third is roots are imaginary. And how imaginary root can be occurred? Always a plus minus ib, this form, a plus minus iota b. Then CF or solution is equal to a1, sorry, e to the power a x into a1 cos bx plus a2 sin bx. These three forms you have to remember. Okay, according to these three rules, now let's check out the solution of this one. This is real and equal form. So real and equal form means which formula you have to apply? Real and equal formula, that is this one, second, a1 plus a2x into e to the power mx. So m is equal to 1. Look at this, real and equal, so m is equal to only 1 here. So the solution is equal to a1 plus a2. Okay, here instead of x, t is used. Okay, so it is a t into e to the power minus t, minus 1 into t, that is minus t. So this will be the answer. Yes, exactly, Mohit, your right answer. This is the right answer. Okay, here instead of x, t is used. That is why we have used a t here. So exactly the same thing happens for each and every equation, which is the second order equation with constant coefficients. Okay, and if I put these values, so this is y solution. Now y0 equal to 1. Okay, tell me, I have already found the solution. Now we have two values, y0 equal to 1 and y dash 0 is equal to 2. Y dash means dy dx or dy dt. Dy dt equal to -2. Now please tell me what is the answer. That is, this is the general solution. What is the particular solution? If I put y0 equal to 1 and dy dt is equals to -2 here in this solution, what will be the values of a1 and a2? a1 equal to 1 and a2? minus 3. Minus 1. I'm getting different answers. Okay, let's put the value here. First, here we are finding it is t is equal to 0, y is equal to 1. So put here t equal to 0, y equal to 1. T equal to 0 means e to the power minus t becomes 1. Okay, and here only a1 is equals to 1. Yes, a1 is 1. Okay, a1 is 1. Because if I put the first condition, when t equal to 0, y equal to 1. So put here t equal to 0, a2 becomes 0. A2, there will be no a2 term. And e to the power minus t. E to the power minus t means e to the power 0. It is 1. And y equal to 1. So a1 equal to 1. a2. Now second, take the derivative dy dt. Dy dt, it means if I take the derivative, then it becomes it equal to minus 1. Okay, e to the power minus t, then a1 minus 1 e to the power minus t plus a2 plus a2 e to the power minus t into the power. Okay, first it is e to the power minus t plus, okay, it becomes minus t. Okay, dy dt. Okay, first second one is y dash 0 equal to minus 2. Y dash 0. 0 means it is 1. It becomes 0. It is 1. It is 1. It is minus 2. Dy dt equal to minus 2. Y dash 0. This is y dash. Dy dt equal to y dash. So the condition is y dash 0 equal to minus 2. So dy dt value is minus 2. Put here minus 2. And t is equals to 0. Put here t equal to 0. If I t equal to 0, a1 is equals to already 1. Put here 1. It becomes 1. So 1 into minus 1 plus a2. It becomes 1. This one. So it means it is minus 1. A2 is equals to, it is plus 1. Yes, minus 1. A1 equal to 1. A2 equal to minus 1. A1 equal to 1 and A2 equal to minus 1. Any doubt? Okay. Next. This is easy, but solve it. This is easy question, not a very difficult one. Complete solution of the differential equation is given as this one. And solution is given, you need to find out the value of P and Q. Okay, one thing, this is C1 e to the power minus x, C2 e to the power minus 3x. Okay, this is wrong. C. Okay, two of you says C. Any other answer? Okay. First of all, we'll look at the formula first. And this solution. The solution here is given as C1 e to the power minus x plus C2 e to the power minus 3x. Tell me, look at the rules. Which one? Rule 1, rule 2, rule 3. There are three rules. Which rule matches the most? Real and unequal. Obviously, this one, rule number 1 matches the most. Okay, so if rule number 1 matches the most, it means the roots will be real and unequal. And what are the rules? Roots. The roots are m1 and m2. So, can you find from this formula, from this solution, c1 e to the power minus x and c2 e to the power minus 3x? So, what are the roots of the auxiliary equation of this? That is that m square equation. M square. Obviously, if I convert this equation with m square form, it becomes m square plus p into m plus q is equal to 0. This is the auxiliary equation, m square equation. And if I consider this is the solution, and this solution matches with real and unequal root. So yes, obviously the roots is minus 1 and minus 3, because e to the power minus 1 into x, and this is e to the power minus 3 into x. So m1 is equals to minus 1, m2 is equals to minus 3. Okay, if this is, and these two roots m1 equal to minus 1 and m2 is equal to minus 3 is the root of the equation, then these two roots, obviously we have got these roots by solving what equation? This equation. After solving this auxiliary equation, we can get this root, isn't it or not? And this equation is nothing but a polynomial in M. Okay. Now already I have discussed this matter in some previous class. If m1 equal to these two things are the root of this equation, then what are the factors? Suppose minus 1 is a root of this equation, which is polynomial in M. Then what is factor? What is the factor? Can you tell me? Exactly. M plus 1. M plus 1 equal to only M plus 1. M plus 1. And M equal to minus 3 is another root. If minus 3 is the root, then what will be the factor? M plus 3. Then how many factors you can got? You can have two factors, M plus 1 into M plus 3. And obviously M plus 1 into M plus 3 will be equal to what? M square plus PM plus Q will be equal to this one or not? Am I right? Am I right? Did you get my point? If roots are given, we can have the factor. And obviously that factor can be obtained by simplifying this equation, which is given m square plus pm plus q. Obviously m square plus pm plus q will be equal to the multiplication of these factors. Now can you find what is the value of p and q now? Option C. C. Okay, everyone is saying C is the answer. So simply, if I now just multiply m square plus 3 plus 4m plus 6. Okay, so P is equals to what? Just compare both sides. M square is matched, and coefficient of m is 4, so P is equals to 4.
It is three, sir. Constant.
Sorry, it is 3. Yes, 3. Q is equals to 3. So P is equals to 4 and 3, Q is equals to 3. C is the right answer. This is a very tricky question. Very easy, but very tricky. Next. This is easy. You have to solve it. I won't solve this one. And tell me the answer. Only I have got two answers. What about the others?
So just a minute, sir. I'm solving it.
Okay. Okay, so let's solve this answer. Y double dash plus 2y dash plus y double dash means it is second order, 2y dash means first order, y means first order, so it is 0. So after applying the rule, it is m square, it becomes m square. Double dash, double derivative means always m square, plus 2 into single derivative means it is m, plus y means it is 1, is equal to 0. Solve it and we are getting same case, that is the same answer we are getting, m plus 1 into m plus 1 is equal to 0, that is m is equals to minus 1 comma minus 1. Am I right or not? Just yes, right, yes. Minus 1 minus 1. So what is the CF? CF means only, okay, remember one thing, if right hand side is equal to 0, there is no other term of x. Okay, right hand side equal to 0, then the only CF, that is whatever the rules we have discussed now, will be the solution of the differential equation. That is y is equals to uh, real and equal. It means a1 plus a2 x e to the power minus x is the solution. Now y1 equal to 0, sorry, y0 equal to 0, y1 equal to 0. Y0 equal to 0, if I put y0 equal to 0, it means when x equal to 0, y equal to 0. Put here y equal to 0, put here y equal to 0, a1 plus a2 x equal to 0 means this becomes nullified and this is 1. So a1 equal to 0, a1 equal to 0. And if I put y1 equal to 0, y1 equal to 0, it means x equal to 1, y equal to 0. Okay, yes, x equal to 1, y equal to 0. So y equal to 0 means it becomes now 0 is equal to a1 plus a2 e to the power minus 1. Okay, a1 is already 0, so it means a2 is equal to, sorry, a2 e to the power minus 1 is equal to 0. Okay, e to the power minus 1 never be 0, because we know the value of e is in between 2 and 3. Okay, so e to the power minus 1 never be 0, so obviously a2 equal to 0. Yes, a2 equal to 0. a1 equal to 0, a2 equal to 0, it means y equal to 0 is the only solution. So y equal to 0 is the, if it is the solution, then y 0.5, it is obviously 0. Okay, it is A. A is the right answer. Any doubt? Okay, particular integral. Particular integral, I don't have much time to discuss about it because particular integral has many more rules. So I have to discuss this particular integral in the next day. Yes, solve this one. Very, very, very important question. Okay, two conditions, two boundary conditions are given, y equal to 0 for x equal to 0 and y equal to 0 for x equal to a. Boundary conditions are given, you need to solve it. Exactly similar as the previous question, but this is a trick. There is a trick. Okay, I think you are facing difficulties. Okay, let's first simply find the answer. D2y dx2 plus k square y.
So I'm getting it
Yes,
as K, sir.
k, only k.
The root, which means K and K.
No, 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 no. Not k and k. It will be imaginary. Look at this. If I solve this one, d2y, it means m square plus k square is equal to 0.
Yes, sir, right, sir.
M square equal to minus k square. It means m is equal to plus minus ki.
KI, yes, sir, correct.
So if it is m equal to plus minus ki, obviously it is m is equals to, I can write it 0 plus minus ki. Okay, so if I compare this as a plus minus ib, it a is equals to 0 and b is equals to k. Okay, now just to go to the rules. Rules. Yes, go to the rules. Imaginary rules. C e to the power ax, a1 cos bx plus a2 sine. So now we have got y is equal to, since right hand side equal to 0, then the CF will be the answer. So y is equals to e to the power ax, means e to the power 0 into x. It means e to the power, it becomes 1. So we don't need to write a1 cos b equal to k, kx plus a2 sine kx. This is the CF or the answer. Now put the conditions. Okay, boundary conditions. For x equal to 0, y equal to 0. Okay, y equal to 0, x equal to 0, it means first condition 0 equal to x equal to 0 means a1 cos 0 equal to 1, but a2 will be 0. So a1 equal to 0. Next, y equal to 0 for x equal to a. Condition 2. If I put condition 2, y equal to 0, x equal to a. So a1 cos k into a plus a2 sine k into a. Okay. Okay. A1 is already 0. So we don't need this term. So only it is a2 sine ka. Right. So if a2 is not equal to 0, if a2 is not equal to 0, if I consider, then obviously sine k into a equal to 0. Now you have to go to the rules for class 12, class 11 trigonometry. Okay, 11th class trigonometry. If sine k into a equal to 0, or the rule is sine theta is equals to 0, then theta equal to what? Theta is equals to n into pi, for n is equals to 0 plus minus 1 plus minus 2 plus minus 3 and so on. This is the rule for trigonometry for class 11. So just we need to put here same thing here. So sine ka is equals to 0. It means k into a is equals to n into pi. Okay, so k equal to what? So we need to find out the value of k is equal to n pi divided by a. Just put the value of k into this equation. Okay, now we are putting this value. So now for different values of n, so n is equals to, it may be 0 plus minus 1 plus minus 2 plus minus 3 and so on. Okay, now put the values into this function, that is, sorry, into the solution. A1 is already 0, so we don't bother about the A1, what A1 is. Only we have found the value of A2. So it means if I put the value of k, so it means y is equal to, Look at my answer. A1 is 0, we don't need to find it. First we put, suppose n is equals to 1 or n equal to 0 or n equal to 1, suppose. So it becomes a a2, it itself a suppose a constant. Okay, itself a constant. So if I put n equal to 1, suppose I am considering it a1. Okay, I'm just considering, since it is a constant, I can place it anything. I can replace a2 by a1 or a3 or something, anything. Okay, sine k is equals to, first k equal to what? N pi by a. X. Okay, so for n equal to 1, it becomes 1 into x. For n is equals to 2, it becomes y is equals to a2 sine 2 pi by x. For n is equals to 3, it becomes y is equals to a3 sine 3 pi by x. For n is equals to 4, a4 sine 4 pi by x, and so on. The solution will be the addition of all these things. Okay, so it means A is the right answer. Summation of am sine m pi x by a. This one. Summation over m. M means here n is considered as m and nothing else. Okay. Can you get my point? Hello? Am I audible? Can you get my point? Is it clear to you?
Yes, sir.
Okay. So this is okay. So only another thing is given. It is already 8:04. Okay. So I have to end the session right now. Two things are left. One is finding of particular integral, the important part. Other part is, it is constant coefficient, is variable coefficient. There is Cauchy-Euler equation. That is easy part. Only you some minutes it can take. PI finding is important. I will discuss the PI finding next day. And then only one thing is left, which is complex. Okay, so I am ending the session here. If you have any question, collect it and ask me the next day.
Thank you, sir.
Thank you for attending my class.
Sir, next class will be on next week.
Next class will be on Monday, I think. Monday.
Okay, sir.
Okay. Yes.